All right, so starting on page 44, you'll see a title that says arithmetic sequences. And yes, you can also pronounce it arithmetic. And it says, do you see a pattern in each of the sequences? So they give you a sequence of numbers. The first one here is 3, 7, 11, 15. So the question is, what do these patterns have in common? But first, we want to see what is the pattern. We can tell it's increasing. So what are we adding each time? Yes. 4. Correct. So if we're adding 4 each time, and that 4 is not changing, so I'm going to put a plus 4 because we're adding 4. Each time we're adding 4. We're not adding 4, then adding 2, or adding 3. We're actually adding 4 each time to get to the next number in the sequence. Okay? If I take a look at these set of numbers here, okay, first thing I notice that they are decreasing. So then I look for a pattern. Well, what is it decreasing by? What am I subtracting each time to get from one number to the next? Yes. All right, I'm subtracting 5. Right? So, again, it's consistent. Each time I'm subtracting 5 to go from one number in the sequence to the next. So the numbers in the sequence are called your terms. The difference between the terms is called the common difference. So just a little vocabulary. And it says if the difference, that means what you're adding or subtracting, so it's just not for subtraction. If what you're adding or subtracting between successive terms is constant, that means it is not changing, then you have what we call an arithmetic sequence. Now, you can definitely have a sequence of numbers that's not arithmetic because it could still have a pattern, like, you know, where you're adding 2 and then you're adding 3 and then you go back to adding 2 and then you're adding 3. That is definitely a pattern, but it's not considered an arithmetic sequence because you're not adding or subtracting the same number each time. Okay, any questions on that? How you determine if it's an arithmetic sequence. All right, so the good thing about an arithmetic sequence is there is a formula. Formulas are terrific because all you do basically is insert the numbers in their proper places, use the formula, and then you can find out what is the 100th term in the sequence. Okay, because if I go back to this problem right here and I say, okay, we're adding 4 each time, then what will be the 1000th number in the sequence? Now, of course, you will not want to write down plus 4 every time until you get to the 1000th number. Okay, so that is what this formula right here will allow you to do, is to get any number in the sequence you want. So if I wanted just the 100th number, I could do that. Or if I wanted the 25th number, I could use this formula to find out whatever number I would like. So let's look at what the variables represent in the formula. And like I said, formulas are great because I even put a key over here to indicate what each variable represents. So if you see n, which you will right here, the n represents the number of the term we are looking for. So if I wanted to find a 50th number, then I would replace n with 50. Okay, if I wanted to find the 20th number, then I would replace n with 20. So you guys get the idea. A sub n is just really the answer. Okay, so that's why it says equals a sub n. So I would say, like, if, you know, again, if I'm looking for the 20th number, that little n that's right here will just look like this. The 20th number in the arithmetic sequence equals. Okay, so that's all it is. It's going to be your final answer. A sub 1, this is very important, and it's very important to pick out because it just says it's the very first term. So if I go back up here and I say, what is a sub 1, you would say 3, because that's the first term in the sequence. Okay, that is the first term in the sequence. So that's what a sub 1 would represent in this formula right here, is the very first term. So we only have one more variable left, which is d. D is your common difference. Common difference means what you're adding or subtracting. So if I go back up here, the plus 4 would be my d. If I go on this side, the minus 5 would be the d. The common difference is what you're adding or subtracting each time, and that number would go there. Okay, so that's what the numbers represent in the formula. Like I said, it's a very easy formula actually to use. So let's try the first example. All right. So looking at example 1, I have the numbers 4, 9, 14, and 19, and obviously they are increasing. And what are they increasing by? Because that's really the first question. Determine what the common difference is. So what would be the value of D? Yes. 5, really. So it's a positive 5, so I'm going to just put a 5 for being positive. I really don't need to put plus. Okay, positive 5. That is my D. So I already know when I use this formula that the D, that 5, will go right there, right? Now, it did not tell me until I get to C, and I'm not there yet, which term I'm looking for. It's telling me in C to look for the 100th term. So eventually, obviously, that's going to be my N. But I'm not there yet. Okay, so I need to stay at B. So in B, it says simply write an equation to find the nth term. That means you're not going to replace N. So if I'm looking for the nth term, I'm going to leave N exactly where it is. I'm not going to even change it until I get to part C, which says to change to 100. All right, so let's see how that works out. So I'm going to write down A sub N, just follow the formula, equals, and now I have to identify A sub 1, which is just the first number in the sequence, which is what number? 4. Very easy. Plus, I have already identified D. My common difference is 5. Now, if that had been negative 5, I would have put minus 5 instead of plus 5. Okay, but it was a positive 5 I was adding each time. Parenthesis, I'm just following what's up here. N minus 1. So remember, I'm not replacing N yet, so that's why it says nth term. That means leave the N right where it is. So now we can simplify this. So let's go ahead and simplify it. And guys, when you simplify this equation, you cannot add 4 plus 5 first. I know that's like the very first thing you want to do. You actually have to deal with the distributive property first. So I'm going to do 4 plus 5 times n, 5n, 5 times negative 1, negative 5. Now I can simplify and add these two together, which will give me A sub n equals, write the term that has the variable with it first, 5n minus 1. Okay. All right, so now I can take this equation, this A sub n equation, which is 5n minus 1, and use it for part C. It says use the equation to determine the 100th term. So now everywhere I see this n, what am I going to replace it with? 100. So 5 times 100 is 500. 500 minus 1. So what is my 100th term? 499. Okay, so that will be the 100th term in the sequence, 499. Okay. All right, so let's move to example 2. Now, when I look at these numbers, the first thing I notice is that they are getting smaller. So that means I am subtracting something. What am I subtracting each time? What is my D? Negative 4, okay? So I'm going to put D equals negative 4. So this time I'm subtracting 4 each time. So I'm going to follow the same formula, but this time my d is going to be -4. So it won't be a plus d, it's going to be a minus d. So I'm going to say a sub n equals, my first term in the sequence is -3. And I'm not going to put plus d because it's a minus, so it's -4 times n minus 1. So I'm going to distribute this out. I'll simplify it to -3 minus 4n, and then a negative times a negative will be a +4 here. So my nth equation is -4n, always write the term that has the variable first, plus what? Plus 1. All right. Now, part C asks for the 20th term. So now I'm going to use this equation and change the n's to 20. So -4 times the 20 plus 1. So -4 times 20 is -80. And what's -80 plus 1? -79. So that will be the 20th number in the sequence. Okay. All right, so that's for arithmetic sequence, and now we're going to move. I'm not going to do example 3 right now. We're going to move on to geometric. So that's arithmetic. So now, if the arithmetic sequence is for adding and subtracting, what do you think the geometric will be for?
Dividing and
Right, multiplying and dividing. All right, so here it says the ratio between the terms is called the common ratio. Okay. And if the ratio between the terms is constant, then it's a geometric sequence. Okay. Different than the other one. So here's our formula, so you might want to just box that or circle it or whatever. The only variable that's different is an r. See, in the other one we had a d, remember? So this time we have an r for the common ratio. So if you look up here, it says 3, 6, 12, 24. What are they multiplying by each time? 2. So that r, and I'm just going to put r, would equal to 2 for this one. Here we're actually dividing by 2, correct? So if I'm dividing by 2, that's like 1/2. Same thing as multiplying by half, dividing by 2, correct? All right, so let's just take a look at the first one here. Actually, let's do example 2. Okay, let's try example 2 first. So in example 2, it goes from 1,000 to 5,000 to 250. What's happening here? We're dividing by 2. Okay, so we're going to say that r equals 1/2 because we are dividing by 2. Okay, we're dividing by 2. All right, now let's go to this one and what is happening. And this, just tell me what r is. We have 2, 8, 32. We're multiplying by what?
4.
So we will just put a 4 for that. Okay. So now let's see if we can follow this formula. It's not a hard one either. Okay, same variables except for there's an r, and then we have like an exponent. All right, so this one says write an equation for the nth, so that means we leave n where it is. Okay, so I'm just following what's up here. Equals my first term. Well, what is the first term in this sequence? We're doing this one, so that will be what? 1,000. Okay, and then what was my r? 1/2 because I'm divided by 2. Is that right? And then I'm still following this formula. It says n minus 1. Now, I cannot go any further than that because according to the order of operations, I have to do exponents first. And since I have not replaced n with a number yet, that's as far as I can go. Okay, you cannot do 1,000 times a half. You can't do that yet because according to our order of operations, this has to be done first. Okay, so since I don't know the value of n, I just leave it there. Now, when I get to f, I can actually change n to 10. So I'm going to say a sub 10 equals 1,000 times 1/2. And what is 10 minus 1? To the 9th power. Okay? So again, according to the order of operations, I have to deal with my exponents first. So in your calculators, guys, go ahead and actually type in on a blank screen 1/2. Okay, put it in parentheses just like that. And if you don't want to use the fraction tool, you could just say parentheses 1 divided by 2, same thing. And then you're going to hit the caret key. You know, the caret key looks like that. And raise it to the 9th power. Okay. Hit enter. And then times it by 1,000. Okay, if someone can share out their answer for me. Okay. All right, and give me the decimal for that. So if you guys would divide it, and then you should have 1 point something. Just give me 2 places out. All right, 1.95 it is. How many people got 1.95 when they actually divided that? Okay, so you should have 1.95 because you do come out with the fraction, and then just take the fraction and divide it because we can actually have decimals in a sequence of numbers and just leave it like that. Okay, we'll just go out 2 places. We'll just go out 2 places. All right, so let's do example 1. Let's go back to example 1, and then we'll be finished. We would have had 2 examples for the arithmetic sequence and 2 for geometric sequencing. All right, so let's go back to example 1. So in example 1, okay, we said that our r equals to 4. So we're going to say a sub n equals the first term in the sequence, which is 2. And then this will just be 4 times n minus 1. So that's all we can do for part E. Okay, part F, we can continue now and put in 20 for n. So a sub 20 equals 2, and then times 4, and then what is 20 minus 1? 19. So, and some of these numbers might get so large until it might even convert to scientific notation on your calculator. We'll see. But go ahead and do 4 to the 19th power, and then times that by 2. As a decimal, you should get like 5.49. Okay, how many people had that? All right, very good, very good. Okay, so for your homework, you're just going to the next page here, and you're doing the odd numbers only. So you might want to put odds at the top, but please pay attention to the directions, because look up here, the first 2 problems up here, which are the odd numbers, it is only asking you for the common difference. So that means what you're adding or subtracting each time, and then write the next 3 terms. Okay, so that's not even using the entire formula. It's just finding out what your common difference is, and then writing the next 3 terms in the sequence. Part 2, this one is where you use the formula. It says find the common difference and the equation using the formula. So you're going to have the nth equation. So you might even want to write the nth equation. Okay, so that means you're not replacing n. And then down here, for the last part, it says determine if the sequence is geometric. So first you got to look at questions 9 and 11 to see if it's a geometric sequence. If it is, then you're going to write and use the formula to the nth equation. Okay, so first you want to determine if it's a geometric, And then if it comes out geometric, then you can give me an equation to the nth term.